Write down the topic. Today's topic, Upthrust. Upthrust. Okay. What mean by the upthrust? Upthrust is the force created by an object when uh, the object in liquid, right? Therefore, if there is an object in the liquid, we know there is pressure created by the liquid like this, perpendicular to this object, perpendicular to this object. Okay, perpendicular to this object mean it create this kind of forces. If the resultant is equal to the upwards, right? It's created if the all the pressure forces are created to the perpendicular to the object, and the total summation of the total resultant must be created into the upwards, right? That is the upthrust, right? Okay, write down. When an object completely or partially, submerged in fluid, completely or partially submerged in fluid, the upward force, which act on the object, write down in brackets, the summation of in brackets, summation of total perpendicular reaction forces, close the bracket, is the upthrust force. It, close brackets, it always act vertically upwards. To the object. Okay. Draw this one. This is the forces created by the pressure. It is over. Acts perpendicular. Okay. Draw this one. Okay. Okay. Write down. Then, if there is a force acting by the liquid on the object, according to Newton's third law, there is a reaction force. Every action has a reaction. It's similar to the size of the action, but the opposite to the direction of the reaction, the direction of the action. So, if the U created by the liquid, then the another force acting on the liquid, it is also equal to the that one, U. It is called the downward thrust. Okay, write down. According to Newton's third law, according to Newton's third law, when the fluid extract in, according to Newton's third law, when the fluid extract upward thrust on the object, upward thrust on the object, upward thrust on the object, the object extract vertically downward force, the object extract vertically downward force in the fluid is called, downward thrust. Downward thrust. Then another rule, the magnitude of upthrust equals to magnitude of downward thrust. Okay. Magnitude of the upward thrust equals to the magnitude of the downward thrust. Direction is changed. Direction is changed. Okay, write down. It's called by the upthrust. Okay. We know there is a point of action when there is a object, when we when we draw the object, we know how can we mark the weight from the center of gravity. In mechanics we discussed center of gravity. Center of gravity means the point of action of the mass of the weight, right? Likewise, there is also the point of action when object submerged like this. There is a force called in upthrust. It also have a point of action that causes the G dash. G dash mean the center of buoyancy, right? Okay, write down the topic. Write down the topic. Center of buoyancy. Write down the topic. Center of buoyancy. Center of buoyancy. It's called by the, then when we mark the when we mark the center of gravity, it's called G. This one called as G dash. Okay. When an object is completely submerged or submerged, we can identify the what is the center of buoyancy. When an object is completely submerged to the water, I take the spherical shaped object. The G in the like this G, it is the center of gravity. Center of gravity when the is a point which act in weight. Then the center of buoyancy also acts from that. Center of buoyancy also acts from it. It is G dash. Okay. Mg and Mg and U. There is a two external forces. So when the cylindrical shaped object is completely submerged into the water, we know what is the center of gravity location. ඒ කියන්නේ මෙයාගේ center of gravity එකේ location එක කොතනද තියෙන්නේ? හරි මැද නේද? In the middle no? So it is the weight. It is the weight, and also this is the upthrust. So it also acting from that. It is not a big deal, no, not a big thing. But when it partially submerged, we know what is the center of gravity. Center of gravity does not change. Center of gravity is located on the center of the G. But the center of buoyancy is located like the shape of submerged. The center of gravity of the shape of that submerged is the center of buoyancy, right? ඒ කියන්නේ මේකේ ගිලිලා තියෙන එකේ මෙන්න මේ ගිලිලා තියෙන එකේ මෙන්න මේ තියෙන shape එක තියෙන්නේ. It is the semi spherical shape. The center of gravity of that one is the center of buoyancy. ඒ කියන්නේ ගිලිලා තියෙන එකේ center of gravity එක තමයි center of buoyancy කියලා කියන්නේ. Right? Then when the cylinder is complete partially submerged, center of gravity means center of gravity is located in the middle point of this one, G. Right? G. The mass acting is mg. Center of buoyancy means the submerged shaped center of gravity of submerged shape. It is this one, u. Okay. Okay, write down. Okay, sorry. After writing the center of gravity, center of buoyancy, G dash, write down this paragraph. The point where the upthrust of floating body, acts is called upthrust of floating body acts is called the center of buoyancy. The center of buoyancy. Center of buoyancy. This point is situated. At geometric center. Of the portion immersed. Or the center of gravity of the displaced volume of the liquid. Displaced volume of the liquid. Right? Okay. This is the water level. So when we submerge object to the water, the amount of the volume of the water get displaced. Who had found that one? That one found by the Archimedes, right? You know there is a 𝙬𝒂 like this one. Yeah, there is a, I think there is a some kind of apparatus called in displaced vessel or Eureka vessel. In the grade 11, we discussed that one. When an object is getting submerged, there is some kind of water get displaced. That volume equals to the submerged object volume. That means when object gets immersed or submerged, so there is a equal volume getting displaced. The displaced volume is equal to the shape of this one, volume of this one, right? Therefore, we can say the center of gravity of this volume. This volume means the spherical volume. That also there is a center of gravity at the center, right? මේකෙන් අයින් කරන වතුර ටිකේ ඒ වතුර වල තියෙන shape එකේ එයාගේ center of gravity එක කිව්වත් හරි. හරි? No need to write this one. This is the Eureka vessel, I think you know. Okay. Okay, write down. Draw this one. Draw this one. I so much. Okay. Okay. Write down. Write down another topic. Archimedes principle. Archimedes principle. Right. Write down topic Archimedes principle. Okay. Write down. We know it. That we studied in grade 11 also. When the object is completely submerged in the water, so it get displaced the some kind of water amount. It's equals to the volume of the object, and also when we get the weight of that water volume, we can get the upthrust force, right? Therefore, the weight of the displaced volume of the water equals to the upthrust force. Okay, write down. Write down. When an object completely or partially immersed in a incompressible fluid at rest, the upthrust force acting on an object equal to the weight of the object displaced by the body. by the object display, the weight of object display. I told the total upthrust force acting on an object equal to the weight of the water which displaced, weight of the water which displaced by the body, right? Therefore, if I take the volume that displaced from the, when we have vessel like this, so we get submerged this object, right? Therefore, when it go like this, it displays some kind of water amount. It's equal to this object, right? I take as V. So the upthrust force acting on an object, right, equals to the, if the density of the water is equal to rho, we can tell the upthrust equals to the displaced volume is V rho into G. V rho means the weight, mass of the water that displaced, right? Therefore, V rho G, the weight of the water or liquid that displaced when the object gets submerged. Okay. Okay. Write down. එකට මෙයා ගිල්ලනට පස්සේ අයින් කරන වොලියුම් එක V. වොලියුම් එක V. එතකොට V කියලා කියන්නේ අයින් කරන වොලියුම් එක. ρ කියලා කියන්නේ මේ ලික්විඩ් එකේ ඩෙන්සිටි එක. T කියලා කියන්නේ ග්‍රැවිටේෂන් ඇක්සලරේෂන් එක. කියන්නේ මේ කියන්නේ V rho කියලා කියන්නේ mass එක. Therefore, V rho G equals to mg. Right? Okay. Write down. If the capital V of the body, if the capital V of the body is immersed in the fluid, is immersed in the fluid, of density rho, the upthrust according to the Archimedes principle is equal right. Write down this one. Draw this one and write down this one. I think okay. This is the liquid volume that we displaced. Therefore, this is the mass of the displaced liquid, right? Okay. We can prove this Archimedes principle. In the older times, we also discussed this one, but we did not prove. But in this case, we can prove this Archimedes principle. Okay, write down. In order to verify Archimedes principle theoretically, we can consider the cylindrical object. Which immersed with axis vertically in the vertically in the liquid of density rho, density rho of density rho. Okay, see carefully, and you have to prove this one, because sometimes they are asking you have to prove this one. Okay, because of that you need to get the clear idea about this one. Okay, I take as the I take this object which completely submerged into the uh, the, that liquid, and this one is the height h2, and this height is the h1, right? h1. So I take the area of this one is equals to the a. Area of this one also equals to the a, right? Therefore, this is the h. H means h2 minus h1, the cylindrical object. Okay, so this is axis normal to the like this. Okay, so when the pressure, what is the pressure acting in everywhere? The pressure acting perpendicular to the object, we know it is in previously we discussed. When an object is uh, completely submerged, the force acting everywhere. But if we think it is perpendicular, there is a force acting on an object in the curved path also. Along the curved path, they are also force acting, but they are getting cancelled out. See, is that real? Yes, they are getting cancelled out. They are getting cancelled out, right? The forces are acting, the resultant force are acting the along the that flat shaped, right? The upper part and the lower part, right? Right. This shape, when this shape is submerged into water, they are also force acting on the third path also. They are getting cancelled out. Why? This force equals to this force, and this force equal to this force. So therefore, the curved path, along the curved path, the total force getting cancelled out. Therefore, reaction force getting cancelled out. That means there is no resultant force along the curved path. There is no resultant force along the curved path. Okay. Okay. Write down this one. Draw this one. Clearly draw. Right. If you are considering the spherical shaped object, there is a force acting along the every direction. So summation of the pressure forces are getting cancelled out, right? The total force acting to upwards, but the pressure acting එකනේ අපි සාමාන්‍යයෙන් ගොඩාක් මේ challenge deep එකට වගේ. ඒ කියන්නේ මරියන් ට්‍රෙන්ච් එක තියෙන්නේ. ඒකේ මේ challenge deep එකට වගේ අපි යවන්නේ ගොඩක් round වෙච්ච මේ submarines. ඒ කියන්නේ round කියලා කියන්නේ මෙන්න මේම ගෝලාකාර spherical shape submarine. ඒකට reason එක තමයි මෙයාලට act කරනවා මෙන්න මෙහෙම forces. එතකොට මේ forces වල summation එක නැත්නම් total resultant force එක act කරන්නේ upwards, but මේ ඒකෙදි ඔක්කොම ටික cancel out වෙනවා. ඒ කියන්නේ වටේට තියෙන curve path වල තියෙන ඒවා cancel out වෙනවා, right? But when we going to that kind of deep, using these kind of things, right? There's the ocean gate. ඒ කියන්නේ ගොඩාක්ම deep එකට ගියොත් මේ ocean gate එක උනත් දැන් මේ අර මොකද්ද ටයිටැනික් එක ගාව තියෙන එක බලන්න ඕෂන් ඩීප් එකේ ඕෂන් ගේට් එක අර මතකද සබ්මැරින් එක මේ මෙහෙම මොකක්ද ඒකට කියන්නේ ඒක ඒ කියන්නේ ගොඩක් උනේ ඒ සබ්මැරින් එක ප්‍රෙෂර් එක මේ හැම පැත්තෙම ක්‍රියේට් වෙනකොට සාමාන්‍ය සර්කියුලර් කර්ව්ඩ් පාත් එකක් වගේ නම් එහෙම ඇක්ට් කරද්දී මේ ඉට්ස් ඕකේ බට් මෙන්න මේ වගේ වෙලාවකදී මේ පැත්තෙනු ප්‍රෙෂර් එකක් තියෙනවා මේ පැත්තෙනු ප්‍රෙෂර් එකක් තියෙනවා. එතකොට අර අන්ඉක්වලිටි එකක් එනවා. ඒ වගේ කේස් එකක් ඉඳලා මේක නිකන් අර මේ පොඩි වුණා වගේ එකක් තියෙනවා. හරිද? ඒ කියන්නේ මොකද ඒකට කියන වචනේ ඒක මොකද කොහොම හරි ඒක එහෙම පොඩි වෙලා ගියා. හරිද? අර චැලෙන්ජ් ඩීප් එකටත් යනවා. දැන් මේ සබ්මැරින් එක විතර නෙමෙයි ගොඩක් ඩීප් එකට යවෙන්නේ. රයිට් චැලෙන්ජ් ඩීප් එකටත් යවනවා මේ සබ්මැරින්. හැබැයි ඒක රවුම් විදිහට යවන්නේ. මම ඒක ඕනනම් වීඩියෝ එකකින් පෙන්නන්නම්. ඒකේ රවුම් විදිහට තමයි යවන්නේ. ඒ කියන්නේ ස්පෙරිකල් ෂේප් විදිහට. රයිට්? ඕකේ. I think ඒක දාගත්ත නේද? ඕකේ. ඊට පස්සේ ලියන්න then write down the force of curved surface got cancel only the force act on object is the force acting on to bottom and upper cross sections. Right. When we take the pressure acts on the bottom or upper cross section, I will take as the bottom one. This is the bottom. There is a cross section A. The forces acting on the object from F. So the pressure created by that one is F over A. Okay. Write down when considering the cross section. Okay, write down this one. Therefore, force equals to P into A. Okay. Write down this one, draw this one, write down this one, and write down this one. Okay. Then write down when considering top of the cylinder. When considering the top of the cylinder, we can tell there what is the pressure acting on that part. I take it as the P1. I take it as the P2. Draw it in the same diagram. Okay. So pressure acting that one is P1. P1 equals to what? Okay, let's go. P1 equals to, if the atmospheric pressure equals to 5 atm, right? The atmospheric pressure equals to 5 atm. Therefore, 5 atm plus H1 rho g. We know static pressure. When we going downwards, H1 rho g increase in the pressure. H1 rho G. Okay, considering top of the cylinder. Okay, then the force acting on this one. That means this one. It is F1. So this one is F2. Force acting on the cylinder equals to what? P1 into A. That means 5 ATM H1 rho G into A. Okay. Write down. Write down. Okay. Then when considering bottom of the cylinder, okay, bottom of the cylinder means this one. The pressure acting on P2. P2 equals to what? P2. Tell me. P2 equals to what? 5 plus H2 rho G. Right? 5 plus 5 ATM plus, I think it's clear. 5 ATM plus H2 rho G. 5 ATM plus H2 rho G. H2 rho G. Okay. Therefore, F1 equals to what? P2 into A. F1 equals to what? 5 ATM H2 rho G into A. Okay, write down. Therefore, we know, sorry, F2, F2. The H2 equals H2 greater than to the H1. Therefore, P2 greater than to the P1. Therefore, F2 greater than to the F1. Okay. Therefore, what is the resultant force? Resultant force acting by the pressure equals to F2 over F1. F2 minus F1. Okay. Right. Draw this one. I had limited space, so I will erase and write. Yes, I have erased some. What is this resultant force mean? This resultant force equal to the upthrust. Upthrust. You have to memorize this one, okay? Because sometimes they are asking to derive this equation. Okay. I think clear. Okay. Jagat nih. Okay. Then what is the resultant force? We can derive. So F1 equals this one, F2 equals this one, resultant force is this one. I taking some. Okay. F1 equals to this. F1 equals to this 𝜋𝑎𝑡𝑚 plus H1 𝜌g. So I take the resultant force. The resultant mean upthrust force. Upthrust force U equal to what? F2 minus F1. F2 minus F1. F2 mean this one. Right? F2 mean 𝜋𝑎𝑡𝑚 plus H2 𝜌g into A minus 𝜋𝑎𝑡𝑚 H1 𝜌g into A. I think it's clear. Okay, let's get substitute this one. Okay. Therefore, 𝜋𝑎𝑡𝑚 pi into A pi A plus H2 rho GA minus pi A minus H1 rho GA. Pi A to pi A cancel out, right? H2 minus H1 rho GA, right? H2 minus H1 mean HA rho G. The upthrust force equals to this one. Upthrust force equals to this one. So this capital U. So what mean by the H into A? Volume of the volume of the cylinder equals to capital V equals to A into H. A into H. A into H. So therefore, upthrust U equals to what? V rho G. This is capital V. So V rho G. This somehow we discussed. We obtain this equation, right? We have to get that one. Okay. Because of that, you have to practice 1 or 2 times. You get familiar to this one. Okay. Bro, this one. right? Okay. Okay. Write down. Uh, object. Example. Object having a an object having a volume 200 cubic centimeter. 200 cubic centimeter. And it's completely submerged into the liquid which having the density rho equals to 1001 kg m minus 3. Find out the upthrust created by the liquid. Find out the upthrust created by the liquid. Okay, find out. Okay, what is the answer? Give me the answer. What is the answer? Yes. U equals 0 G. U equals V rho G. We mean the 200 centimeter cube. That means the 10 to the power minus 2 centimeter to convert to the meter and cube. So the rho equals to 1200. Then G equals to 10. So 200 into 10 to the power minus 6 into, right, 10 to the power minus 6 getting cancel out. Therefore 2.4 Newton. Okay, this is the answer. Okay, write down another uh, case. An object having a density, an object having a density density 800 kg m minus 3 and having a mass having a mass 7.2 kilogram. 7.2 kilogram. Find the upthrust force. Find the upthrust force when an object is fully immersed in the water. Find the upthrust force fully immersed when object is fully immersed in the water. Right. Okay, find out the mass of this object is this one, this one. So find out. Okay. So first of all, we have to find out. First of all, we have to find out what is the V of the object. So how can we find out the V of the object? So we know density equals to mass over volume. No? Therefore, V equals to rho naught m naught. Sorry, volume equals to m naught over rho naught. So the m naught means 7.2 800. Right? 10 to the power 3. U equals V rho G. V rho G means 9 into 10 to the power minus 3. Rho means 1000 into 10. That means 90. Yes, your answer is correct. Okay. Okay, write down. Okay, write down another problem. An object having the density, an object having a density 5000 kg minus 3, 5000 kg minus 3 is released from is released from the water surface, the water surface find out the acceleration of the object in meter square seconds, ms minus 2. Okay, do that one. Take as the volume as V. It's get cancelled out, right? When we release the object, it getting accelerate. Why? It's a very the weight is higher than to the upthrust, right? Again, අපි ගලක් වගේ අතාරනකොට ඒක acceleration එක වැටෙනවා. After that, when it going to the downward the acceleration, then it get the some kind of velocity called terminal velocity. It's discussed in the surface. It's discussed in the viscosity. Therefore, there is a in-terminal velocity that also discussed in the viscosity part. Okay, quickly do this one. we have to find out the acceleration of the object. So the density is this one. Only the given data is this one. So the water surface, you know, what is the density of the water? 1000. Okay. Quickly do this one. Okay. In this case, the what is the acceleration? So we have to get the volume as the V. So mg equals to what? V rho naught. Rho naught means that density of this one into G. Okay. Upthrust equals to what? V rho Wg. So I apply F equals ma to downward direction. So mg minus u equals ma. Okay, mg mean v rho naught g v rho w g v rho naught a. V getting cancelled out. Therefore, no need of the V. Rho naught means 5000 minus 1000 into G equals to 5000 into A. So, this is 4000 into it is 10. So, 5000 A. Therefore, A equals to 8 ms minus 2. Okay, this is the answer. Okay, write down another problem. We have to do some problems in the note. So if you have to memorize that lesson, again you can go through the problems, then do the exam problem or other things. Okay. Then write down an object having a density 800 kg minus 3 is released from the bottom of the is released from the bottom of the tank, bottom of the water tank. Find out the acceleration of the an object to upwards. To upwards. Okay. Do this one quickly. It's going upwards. Why? The density is, this one is lower than to the density of the water. Okay. Do that. Therefore, for that case, we have to apply F equals ma to the upward direction. So u minus mg equals ma. U equals to what? V rho g. V rho w g V rho naught g equals V rho naught a. So V getting cancelled out. Rho w means the 1000 minus 800 G. No, not mean 800 to A. So this one is 200 G equals to 800 A. That means 20/8 equals to A. So that means yes, 2.10/4, 2.5. Okay, good. Yes, is correct. Okay, write down another problem. An object having a density, an object having a density, an object having a density 7,500 kg minus 3. Object having a density 7,500 kg minus 3 and mass 5 kilogram. And mass 5 kilogram is submerged to 5 volume, 205 total volume in the liquid. Total volume in the liquid. Which having a density 1,500 kg minus 2. Find out the upthrust force. Find out the upthrust force. Find out the upthrust force. Okay, fine. Okay, so in this case, we did not, we don't know the what is the total volume also, but we can find out it. No, we only need to consider this volume, but I taking total volume equals to what? Volume equals to mass over density. No? Mass mean 5 kilogram, density mean 7,500 kg m minus 3. So 15 meter cube. So what is the U is? U equals V rho G. V mean this one, the 205 V volume. V mean 1 over 5,000. Rho mean this one. G mean 10. So no need to worry, it's cancel out. So 20 over 5, that means 4 Newton. Right? Okay. So there's another case. So when object in two medium, object submerged, this is in one medium, but when object submerged in the two medium, we have to consider the when we want to take the total upthrust force, we have to consider two upthrust, right? Two upthrust. Okay. I think it's clear. So write down if 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 we want to take before that, write down if we want to take Upthrust in kilograms. Upthrust in kilograms. It can take as U equals upthrust in kilograms. It can be taken as U equals 0. U equals 0. The rho equals to what? Kg minus 3. It is M3. Therefore, answer is kilogram. Write down that also. Okay. Write down if an object is submerged. If an object is submerged. If an object is submerged. If an object is submerged, 2 or more liquid, 2 or more liquid, 2 or more liquid, like this. ඒ කලින් ආන්සර් එකේදී 4.0005 නිව්ටන් කියලා එන්නේ 4 නිව්ටන් කියලා කෙලින්ම එන්නේ මට ආවේ මේ I applied the I not simplifying before the apply 4 නිව්ටන් තමයි එන්න ඕනේ 4 නිව්ටන් 4.005 නිව්ටන් කියලා ආවනම් ඔයා simplify කරලා තිබ්බා ඒක හින්දා තමයි වෙලා නේද okay නැත්නම් කෙලිම 4 නිව්ටන් කියලා එනවා right when we consider the object it's submerged in density in rho 1 density in rho 2 in this case when if we have to take the total upthrust we have to take that separately this is V2 volume this is V1 volume total upthrust equals to U1 plus U2 U1 mean V1 rho 1 G V2 rho 2 G sometimes there is problems considering this case right this type of case okay draw this one and write this one okay then write down a problem an object having a (500 cubic centimeter 500 cubic centimeter volume and It's immersed 3/5 total volume in the water in total volume in the water and the other volume in the liquid which having density 800 kg minus 3/5. Right. Find out the total upthrust. Okay, find out the total upthrust. Okay, find out the total upthrust. Find out quickly. So we have to take the total. U total. U total means U1 plus U2. U1 means V rho G. This is I take as the U1. This is I take as the U2. So U1 means V1 rho 1 G, V2 rho 2 G. So V1 means 2/5 into 500. So we have to take the centimeters into the 10 to the power minus 6, no? 10 to the power minus 6 into 800, 800 into 10. Right. 3/5, 500 into 10 to the power minus 6 into 1000 into 10. So this case is 200 into 8000 10 to the power minus 6. So this case 300,000 and 10 to the power minus 6. So this case 1, 2, 3, 4, 5 minus 1.2 plus 1, 2, 3, 4, 5, 6. This is 3.2 Newton. Sorry, there is a problem, no? 500. No, I think 200. There is 8, no? 1.6. Sorry, there is 8.2 into 8. That point 1.6. 1.6. 4.6. Yes, your answer is correct. Okay, good. So write down another subtopic. Real weight and apparent weight. Real weight and apparent weight. real weight and apparent weight. Okay. When an object is submerged into the water, when it connected to the spring scale, like this, I connect an object to the spring scale. Then it is submerged into the water. Submerged into the water or liquid. So, what is the things happen? So there is a mg mass and the tension T1. In this case, the real weight can be occur. Real weight can occur, right? So real weight can be occur. So I know, considering vertical equilibrium, I can tell T1 equals to mg. This is real weight. But when considering this case, there is a mass mg and upthrust force U and the tension T2, right? There is three forces acting on the object, right? Then I considering vertical equilibrium. Considering vertical equilibrium. So I know T2 plus U equals to mg. T2 equals to mg minus U. This called apparent weight. This called apparent weight, right? This called apparent weight. T plus U equals to mg. This called apparent weight. Therefore, we can tell apparent weight equals to what? Real weight minus upthrust. Real weight minus upthrust, right? Or the real weight equals to apparent weight plus upthrust. Okay. Write down. Write down this case. Okay. Okay. Write down the problem. Write down the problem. We can do the problem according to this one. So write down a water container having a mass. A water container having a mass 5 kilogram. 5 kilogram is on compression balance. Is on compression balance. An object having an object is hang using string and connected to the spring scale which having density which having density 6000 kg minus 3 and mass 2.4 kilogram. මෙන්න මේ වගේ is connected to the spring scale. Then object is immersed in the water, immersed on the water. This is 5 kilogram. So now the spring, this compression balance taking 5 kilogram, this taking 2.4 kilogram. Find out the readings of spring balance and the compression scale. Spring balance and the compression scale or balance after submerging. දැන් අපි කරන්නේ මෙහෙම. අපි මෙහෙම ඔබ්ජෙක්ට් එකක් තියලා ඔබ්ජෙක්ට් එක සබ්මර්ජ් කරනවා වෝටර්. හරි. මෙහෙම ඔබ්ජෙක්ට් එකක් තියලා එයා මෙහෙම ගිලනවා. එතන මේකේ වෝටර් තියෙන්නේ. එතකොට මොකක්ද වෙන්නේ? This spring scale reading get reduced, then this one getting increased, right? So you have to find that one. Okay, find out the two readings of the scalars. Okay, that problem is a water container having a mass 5 kilogram is on compression balance. An object is hang using the spring balance which having density 6000 kg minus 3 and mass 2.4 kilogram. Then object is immersed on the water. Find the readings of the spring balance and compression balance. Find the readings of spring balance and compression balance. Okay, find out. Now I think it's okay, no? I think it's correct. Yes. $5.5. Yes, you're correct answer. When it's submerged into the water, object in a mass mg 2.4 Newton. Therefore, the tension and the upthrust. Okay. So we have to find out the tension because considering vertical equilibrium T plus U equals to 24. So T equals to 24 minus U. So we have to find, before that we have to find total volume. Volume total equals what? M naught over rho naught. 2.46,000. So we have to find the U. U equals to V rho G. 2.4 over 6,000 into 1,000 into G mean 10. Therefore, 0.4 into 10, 4 Newton. Yes. Therefore, we have to reduce that one. T 24 minus 4 equals to 20 Newton. Okay. It's the answer. Yes, your answer is correct. So, the variable thing is the upthrust. When upthrust acts in 4 Newton to upwards, the only liquid it acts in downwards. So, therefore, it getting increase, the scale reading getting increase, right? Therefore, this upthrust create a downward thrust on water. Therefore, compression scalar reading equals to what? Equals to what? 50 Newton. First of all, it having a 5 kilogram, 50 Newton plus 4 Newton. That means 54 Newton. Okay. The case. Okay. Right now, I think your answer is correct. Yes. Then write down the subtopic. Taking an equation. Write down the subtopic. Taking an equation to specific density. To specific density. To specific density using Archimedes theorem. Using Archimedes theorem. Okay, what is the relative density of specific density? You know, relative density means density of an object or matter, density of water. D equals to rho over rho naught. We know that thing, right? We know that thing. So, when we consider the same volume of the density of an liquid, rho over rho W. When we consider the same volume of an liquid and the water. So, this is V. This mass is M. This is MW. Okay. Therefore, D equals to what? Rho over rho W. the rho equals to what? M over V. Rho equals to what? Rho W equals to what? MW over V. ඒ කියන්නේ අපි same volume consider. We are considering same volumes and taking the masses. එක container එකකට අරගෙන ඒකට මේ එකම volume එක ගන්නවා. ඊට පස්සේ ඒකෙන් mass එක consider කරලා mass ටික ගන්නවා. Right? Then මේක අපි කලිනුත් කරා D equals to what? Rho over rho W. Rho means M over V. M over MW over V. V to V cancel out. M over MW. D equals to M over MW. Right? Okay. Write down this one. Write down this one. Okay. Then write down when an object. Okay. Write down. Before that, write down. Okay. Okay. Then write down when an object completely submerged in water, the volume equal to the volume get displaced similar to the volume of the object. Because of that, කියලා තමයි එකක් දාලා යන්න. Because of that, therefore relative density. How can I take the relative density? Relative density can be taken as the mass of the object. MW means weight of the mass of the water, right? When it's submerged, I know mass of the object is okay. So mass of the water means mass of given volume of object of liquid mass of the given volume of the liquid, mass of the displaced volume of water. It can be right as this. Okay. According to the Archimedes theorem, we know volume of object or object. I think. According to the Archimedes theorem, mass of displaced volume equals to mass of displaced volume equal to upthrust force. So therefore, relative density can be taken as relative density taken as mass of the given volume of the object. That means mg. Mass of displaced volume of the water. That means upthrust. Relative density equals to D equals to mg over u. I think you are correct. Clear now, right? So write down the problem according to this theory. Weight of an object measure using weight of an object measure using spring scale. Spring scale. The reading is 1.2 kilograms. 1.2 kilograms. When an object completely submerged, when an object completely submerged in the water, in the liquid, in the completely submerged in the water, the reading of the spring scale is 0.4, 0.8, 0.8. This one 1.2 kilogram. නිකන් අපි එල්ලලා තියෙනකොට 1.2 kilogram. When it completely submerged into the water, the reading is the 0.8 kilogram. 0.8 kilogram. Find the relative density of the water. 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 Of the object. Sorry. Find the relative density of the object. Relative density of the water. Negative. Right. Okay. Quickly find out. අපි මෙහෙම නිකන් තියෙනකොට 1.2 kilogram මේක මෙහෙම තියෙනකොට 0.8 kilogram මේක submerge කරාට පස්සේ so we have to find that one, the relative density. Okay, for that case this is the only the T equals to the mg, T1 equals to mg, T1 equals to mg. That means mg equals to what? 1.2 kilogram into 10 to 10, that means 12 Newton. So that's okay. So in this case T U mg, considering vertical equilibrium, T plus U equals to mg. T plus U equals to mg. T equals to what? T mg minus U. Mg means 12 Newton. T equals to what? 8 Newton. Mg minus U. So we know the mg. So mg is 12 Newton. U equals to 4 Newton. So we can tell, no? D equals to what? Mg over U. Mg means 12 over U equals 4. 3. Specific density is 3. Okay, your answer is correct. Good. Okay, then write down. I think it's okay. It's okay, no? Okay, then write down the topic flotation. Write down the topic flotation. Write down the topic flotation. Flotation, right? Flotation means floating objects. Okay, write down the topic flotation. Right. What is the flotation? What mean by flotation? If an object is floating, it is the flotation. So the center of gravity is this mg, then it's the center of buoyancy g dash u. Okay. Okay. Write down. If a object is float in, if an object is float in a liquid, the forces mass and upthrust is in equilibrium state. Therefore, when considering this one, mg equals to u. Mg equals to u. Right? Okay. Draw this one. This relation is the taken as the floating principle of flotation. Mg equals to u. Why? When floating object having an upthrust and mass, weight. Okay. Okay. Draw this one and write down. This relation is known as principle of flotation. This relation is known as principle of flotation. Principle of flotation. The center of gravity, capital G, and the center of buoyancy G dash, should be lay on one line. a line, if it is, if it not, U and Mg creates the couple of force. Okay, see, when G in this, G dash in this one, therefore it's rotating, right? Rotating. Okay. Draw this one. Mg and U act as a force. Couple of force. Okay. Quickly draw that one. Okay, quickly draw that one. Okay. Okay, write down. Consider an object in next rule. Consider an object which having total volume capital V, and density sigma, total volume capital V, density sigma. Sigma means the symbol is this one. Sigma is submerged on simple V volume, in the liquid density rho. Okay, draw this one. We can mark forces, no? So center of gravity G act in the Mg, and the upthrust G dash. Upthrust act like this. Okay, draw this one quickly. Draw this one. Okay. Okay. I consider the equilibrium of the forces, right? Considering vertical equilibrium. Considering vertical equilibrium, I can say U equals to Mg. That means V V, simple V, no? U equals to what? Simple V rho G. Simple V rho G equals to M. M means V into sigma. Capital V into sigma into G. G to G cancel out. Okay. Then I tell V over capital V equals sigma over rho. That means the ratio of the volume that submerged over total volume equals to density of the object over density of the liquid, right? Okay, that means volume of submerged over total volume equals density of the object density of liquid. Okay, this is the case. So volume ratio equals to the volume ratio of the submerged equals to the density of the object or density of the liquid. Okay, I think it's clear now. Right now. Right. Okay. Right. Write down the problem related to this one. A wooden block is floating. A wooden block is floating. A wooden block is floating in the water. In the water. In the water. The submerged volume is submerged volume is 305 of total volume. 305 of total volume. Number one, find the density of the wooden block wooden block. Number two, if an object float on a liquid, if an object float on a liquid, number two, if an object float on a liquid which having density rho equals to 800 kgm minus 3, 800 kgm minus 3. Find the ratio of an object. Find the volume ratio of an object. Find the volume ratio of an object which submerged. There's two problems. right? Find the ratio. Find the ratio. Okay, quickly find out. Okay, I think yes, your answer is correct. So we know mg equals to u. Mg equals to u. Mg means the total volume. Total volume over rho naught into g. U equals submerged volume. CVO5. CVO5 into 1000 into g. G is 10. If you do not memorize this one, this equation, you can directly use this one. Mg equals u. There's no need to memorize that thing. Right? It's cancel out. So rho naught equals to 305. I think 600. No, not 6,000. 600. 600. Okay. So this one is we can directly apply that equation also. So I have not memorized that one. Now mg equals to u v1 over total volume. Mg means total volume into 10 equals to what? Mg means v1 1000 into g. v1 into 10, 8 into v. v1 over v equals to 8 over 10. Right? 8 over 10. That means 8 over 10 means 0.8. Ratio is 0.8. Okay. If an object float on a liquid මේ liquid එකේ liquid එකේ නේද මේ කියලා තිබ්බේ density එක rho 8 kgm minus 3. Then the density of this one is not changing, no? Density of this one is 6. Okay. That means v1 over total volume equals to what? 6,600 over 800. 3 over 4. 3 over 4. Okay. Okay. Is that correct?